Sarahi and Megan are playing tennis. Megan hits the ball to Sarahi, and we want to know the velocity of the ball from the time Megan hits it to the point it hits the ground. You may wonder why this piece of information is important to a player. If a player can estimate the velocity that the ball is coming towards them, they will be more likely to position themselves across the court to hit the ball back strategically. We know that the position of the ball is given at this function. We want to know the ball's velocity. We do this by taking the derivative of the position to get v of t. V of t is negative 8.34x plus 80.98. Let's say we want to find t equals 2 seconds. We plug that into the derivative and get 64.3 feet per second. Or Megan is in the middle of the baseline, which is 13.5 feet, and wants to hit 75 feet away from her. This forms a right triangle. We want to find h, so we can use Pythagorean theorem to solve for h, so we can use implicit differentiation. We will now begin implicit differentiation. Dx over dt will equal 0 since Megan isn't moving. Dy over dt is the velocity of the ball, which would usually be 50 miles per hour, but is converted to feet per second. That is how we got 73.3. We plug in everything we know, our x, which is 13.5, and the dx dt, the y, which is 75 feet, and the dy over dt, which is the 73.3 feet. The only thing we don't know is dh over dt. That is what we will be solving for. All of it added up together, we get 72.140 feet per second.
While we are playing jump rope, we notice that a cylinder is formed right here. So we think, oh, we could find the area, but we want to flip it around the y-axis. And me and Megan are 1 foot away from each other. The function of one jump rope is y equals 2 minus x squared, and the other jump rope's function is y equals x squared. We need the surface area of the cylinder, which is 2 pi rh. The height of the cylinder is the length of the vertical slice, and we find that by subtracting the two functions, and the radius of the slice is x. And we use the formula 2 pi, the integral from a to b, x, f of x minus g of x dx. And we set up our integral based on what we know, and we distribute the x, and we integrate, and we plug in 0 and 1 into our integrated form, and get pi.
It takes Sarahi 4 minutes to ride her skateboard from Heineke's classroom to the tennis courts. We want to find out what her velocity at a particular time in the interval 0 to 4 feet per minute. We collected data needed to provide a proper table as shown in the next slides. We want to find Sarahi's average acceleration in the interval. We will be looking at the data table. In this case, we will take the highest and lowest points and create f of 4 minus f of 0 over 4 minus 0. We will get 45 over 4, leading to the answer acceleration is approximately 11.25 feet per minute. Next, we have the integral from 0 to 4 v of t dt. We'll use a left Riemann sum with 7 subintervals. To solve a Riemann sum, we can use a sock method as shown. Say we look at the second sock drawn, we will subtract 1.5 minus 1 and multiply it by 27. We continue to follow this method until all intervals are calculated and added. Basically, the meaning of the integral from 0 to 4 shows the total distance covered from point A to point B. This Riemann sum total will be. We then want to know if acceleration will equal 0. While looking at the data table, we see that velocity equals 30 at 2 points. We subtract f of 2.5 minus f of 1.5 over 2.5 minus 1.5, and we get 0. By MVT, a of t is capable of equaling 0 in the closed interval 1.5, 2.5.
Megan, Jahara, and Sarahi are playing keep away because Jahara was being a ball hog and we want to ensure that she doesn't get the ball. So I have one different function and Megan has another different function. And the balls intersect at a specific point, and we're going to find the area under these two functions. We're going to find the area below the region Jahar is under. Megan's function is square root of x plus 1, while my function is 8 minus x. Since there are two different functions and the balls intersect, we're going to integrate separately at 0, 4.807. We write the area is square root of x plus 1 dx plus 1/2 base times height, and our height is 3.193. And we integrate the expression square root of x plus 1, and we evaluate. And we plug in. And we also found the area of the triangle, which is made under my function, and it is 7.2105. And we get 19.0435. We take the inverse of our two functions, and we get x equals y squared minus 1 and 8 minus y. Our height is 2y, and if we subtract those two functions, we get the width, and our integral expression is going to be from 0 to 3.193 2y times the width dy. If we get the derivative of g of x, we get -1, which means that a line perpendicular to the graph of g has slope 1, and if we get the derivative of f of x, we get 1 over 2 square root of x, and we set that equal to 1, and that way we get x equals 1/4. And we also equal 2 square root of x to 1, and we get the square root of x equals 1/2, which we get 1/4. So there is a point P in which Megan's ball is perpendicular to Sarahi's function of her ball, which is 1/4, 1/2.